Hey, thanks, Brian. Welcome, everybody, to Considerations and Concerns for Platform Plugin Development. I'd like to tell you a little bit about what I do day to day. So, I joined Liquid Web back in 2017. We then acquired another hosting company called Nexus in 2019 because we really wanted to step up how we were handling managed applications. So since we acquired Nexus, I've been the lead developer on the platform-wide MU plugin, which runs across tens of thousands of sites. So Nexus Managed Applications, or MAPS, as it's known within the company, is a must-use plugin that's installed across all of our WordPress, WooCommerce, and Store Builder sites, all of the managed ones, I should say, and then automatically updated. Now, instead of pre-installing a bunch of plugins like some hosts will do, and admittedly, like we had been doing before, this acts as a central location. We can bundle all of the essential items that we need to ensure that our customers have great sites, and then we can intelligently turn them on and off. And I'll show you how we do that in just a moment. Now, building something of this scale, of course, presents a certain set of challenges. First and foremost, every site is going to have some unique combination of themes, plugins, configurations. So how do we accommodate all of our customer sites? Next, certain features might only be available on higher plans, or you might have something that's, say, WooCommerce specific, and someone running just a WordPress site doesn't need it. So how do we toggle these on and off without releasing a dozen different variants of our plugin? Next, the solution that we release is going to impact tens of thousands of sites. So we need to make sure that we're not going to break anything. And finally, one of the major advantages that we tout of our platform is performance. So the last thing we want to do is be the reason a site is slow. So performance is a huge challenge. So the goal for today is not to have a half hour of me going, hey, look at this thing we built, isn't it sweet? It is, in my opinion, but I'm clearly biased. No, instead, I want to show you how we've arrived where we have. So look at the plugin architecture, talk about some of the things that have worked really well, and maybe some of the things that haven't gone as well as we had hoped, and then extract some lessons that you can take to your plugin of any size, whether you're working for a competitor of ours, working for a larger company, or building your very first WordPress plugin. Now, some of these topics are certainly talks in and of themselves. So I'll be sure that Brian shares out a list of resources I've prepared with links to other talks and articles and things too. So if I whet your interest with something and you go, that sounds important, like I should follow up on it, you'll be able to do so. So going back to this list of challenges, really they're not that unique to what we're building. After all, if your plugin is running on even a handful of sites, don't you face a lot of these same challenges? So let's start by talking about the plugin architecture. Before we get into the specifics of how we're addressing these challenges, let's take a look at how it's structured. Now, we'll talk through each of these items individually, but at a very high level, this shows how they all connect. Now, the green nexus-maps.php file over there on the left is our bootstrap. And that's the file that lives within wp-content/mu plugins. It's responsible for, as you may guess, bootstrapping the entire thing. We're also taking advantage of an autoloader, so the bootstrap file will load that. Then it initializes our dependency injection container and uses that to resolve our main plugin class, which sets up everything else. So our integrations, our WP CLI commands, and things like, let's start with our settings class. Now, the settings class acts as the brain of the plugin, and it can be injected anywhere it might be necessary. So this gives us a centralized location for things like, is this a production site or is it a staging site? What's the plan code? What's the customer account ID, etc. Now, we're able to read all of these raw environmental details through a service called Interworks, which is part of our platform's infrastructure. We then do a little bit of light processing, and we're able to get useful insights like, hey, is this a managed WooCommerce site? Or is it just a map site? We can change how we're functioning based on this information. Now, the settings object is often injected into what we call integrations, which are basically the building block of the plugin. You can think of them kind of like Jetpack's extensions, But rather than giving a UI to turn most of them on and off, instead, we're doing that based on the environment, the customer's plan, active plugins, etc. Very often through things that we learned through that settings object. So it's a way to logically group this functionality. Now, we also have a number of PHP traits that we can apply to particular integrations if they require certain functionality. So things like has cron events. Not every integration would necessarily have cron events, but when we do, we can pull in these methods. Every integration defines a should load integration method, which is meant to decide, based on the information I have, should this integration be loaded? Yes or no, true or false. So should this integration be loaded on a staging site? Maybe the integration is only needed if Jetpack is installed and active. Meanwhile, if this method returns false, we just completely destroy the instance of the integration. So that lets the garbage collector come and clean it up. We're not hogging memory that we don't need because ultimately we're not continuing to load this particular integration. It's pretty cool. Now, assuming the should load integration method passes, we get to our setup method. This is where we actually hook everything in for the integration. So this is usually going to be things like registering actions and filters, but some integrations also need to load plugins that we bundle with the MU plugin, or perhaps otherwise start up different service classes. So there's a lot of flexibility in what we can do within our integrations. Similarly, we have the WP CLI commands, which are technically available to everybody, but they tend to be more targeted at internal use. They're all hidden under the NX maps command namespace. So, for example, when a new site is provisioned, the very last step of the chain is calling our setup command to pre-configure sites. So this is going to do things like set default permalink structures. It's going to pre-install any premium plugins that we've bundled or that come with your plan, enabling object caching, page caching out of the box, etc. Our set of commands also includes those to help our support team. We have WP CLI commands in there for flushing like every known cache, which that was a fun one to build. Cleaning up after migrations. If you're coming in from other hosts, we can automatically clean up some of the files they might have left behind. We can also create self-destructing temporary support users that after they haven't been used for 72 hours, they're just removed automatically. It's pretty cool. So this covers the three rightmost items in blue there, but what's this big orange box around them? Well, this is our dependency injection container. The DI container lets us define the dependencies for each integration, service, etc., and then let the container recursively resolve them. So this saves a bunch of unnecessary instantiation of objects, which then in turn saves memory. So for example, instead of manually instantiating all of these objects, we can tell the container, hey, give me an instance of some integration. It goes through the definitions that it knows for these different classes, builds everything that we need, and gives us that instance. Now note that unlike some instances of DI containers that you might be used to, like Laravel, we do not use any sort of auto wiring within the MU plugin because unfortunately that does come with a performance cost. If every time you say, hey, go give me all of the dependencies, PHP has to go in and say, great, what are the dependencies? Let me try to use reflection to figure these out, build everything together, and then give them to you. So instead, we have to explicitly define them so that we're not negatively impacting those customer sites. Now, the definition looks something like this. It's simply a method within the container class called getConfiguration. Now, it returns an array that maps the thing we're trying to resolve, so we'll call it the abstract, into a concrete instance. So in this case, we're saying in order to build some integration, we need the settings instance as well as the services/some service class. The container then caches all of these results too. So by default, we're only instantiating each one of these objects once. And then the next time we call app-get-settings, it's returning that same instance. So it works in that way kind of like a singleton, but it's not only easier to work with, but it's also way easier to test. Next, the plugin class is the main plugin class, honestly, and its sole purpose is just to set everything else in motion. It has exactly one public method, Bootstrap, which is responsible for loading all of the integrations, including running their shouldLoad integration and setup methods. It also defines constants. It registers WP CLI commands. And we'll see all of this in action in just a second. Now, because MU plugins don't get activated in the same way as regular plugins, we need to define a single entry point. In this case, it's that wp content/mu plugin/nexusmaps.php file. So this is an abbreviated version of the Bootstrap file with a few key things to note. First, we're wrapping the whole thing in a try-catch block. So if anything goes wrong loading our plugin, chances are we're not going to white screen the site, which is kind of important. Next, we're pulling in the autoloader. We're creating our single instance of the container and using that to resolve the plugin class. And then we're calling that Bootstrap method on the plugin. So excluding the try-catch block here, we're bootstrapping our plugin in 3 lines of code, which is pretty impressive. Now, if you've noticed a severe lack of require once statements, that wasn't for the sake of brevity. No, instead of loading every plugin file into memory on every request, we can take advantage of PHP's autoloading feature. If you haven't worked with autoloading before, essentially we're telling PHP how to resolve class names to file names. So when a request is made to a class that PHP doesn't know about, it knows where to find that definition. If you're using Composer, even better, you can generate the autoloader for you automatically. And that's going to look something like this. Now, the standard autoloading pattern these days is PSR4, where the file names match the class names and the namespace structure. So my company/my plugin/some class is going to map to source/someclass.php. Because we've told it anytime I ask for something that you don't understand in my company/my plugin, look in the source directory. So with that Composer generated autoloader, we can replace these require once statements and have a single call to require once vendor autoload.php. And then every time we call one of the classes that's covered by that autoloader, PHP automatically pulls in the file. So when we say new some class, for instance, it knows that's in source/someclass.php. Some other class is within source/someotherclass.php. It's pretty handy. Now, this is a pattern that I've seen a lot, and admittedly, early versions of the MU plugin took advantage of until it came back to bite me. Treating class constructors like default methods. No bueno. In this example, anytime an instance of some class gets instantiated, it's going to register those hooks because at the bottom of the constructor, it's calling this register hooks. So if you have multiple instances of some class, you're going to have multiple callbacks, which then can lead to all sorts of fun issues to troubleshoot. Remember that in object-oriented programming, the constructor is meant to provide the instance with any dependencies it might need, but it's not meant to be some default method call. So a much better approach then would be to instantiate the class, then call the method. So in our plugin class, that's going to be the Bootstrap method. In our integrations, that's the setup method. This also helps make things compatible with the DI container because we're only bootstrapping the object when we actually intend to, rather than every time someone says, hey, I might need that. So if we go back to this list, the architecture of the plugin does help address some of these. For instance, we're using namespaces to prevent us from conflicting with other code. So that hits on 1 and 3. We can selectively activate and deactivate integrations based on the environment. So that's 2 and 4. Autoloading and dependency injection, that makes sure that we're not loading a ton of unnecessary code on every request. So again, that speaks to the performance, number 4. But there's more we can do. So now we're going to take a look at how we get our code out to those thousands of sites. But before we do, in front of all of WordSesh, I want to tell you right now that it is absolutely fine to require a build step in your plugin. I promise you. I don't know how, but developers in the WordPress community seem to have this thought in their heads that when you download a zip file of a branch from GitHub, you should be able to install that directly and run the plugin. And frankly, that's not how software in 2021 is made. Now, this might be caused in part by the WordPress.org plugin repo, because that Subversion repo is meant to be for distribution, not for development. But doing things like committing third-party dependencies or compiled CSS and JavaScript, these things are only going to make code review difficult, they're going to invite merge conflicts, and they're going to inflate the size of your repo. So it's okay to have a build process. We have one. WooCommerce has one. Jetpack has one. Heck, even WordPress Core has been modernizing their build process over the past few years. And with good reason. There are a lot of really cool tools out there. We have things like package managers, so Composer for PHP dependencies, NPM and Yarn for JavaScript. We have build tools like Webpack. And if you don't want to deal with configuring Webpack, I don't blame you. We're using Laravel Mix, which is a wrapper on top of Webpack that automates out a lot of the really annoying stuff. Remember that the tooling is there to help you produce the best possible outcome. So use whatever tools make the most sense and help you the most, and then use those to automate whatever you can. For instance, we literally have a maps:build Composer script within our project that will build a production-ready zip file. We can use it to build that, to test it out in staging environments. We can do it locally, and it's the exact same script that we run as part of our CI/CD pipeline. What's CI/CD, you might ask? Well, continuous integration and delivery, or CI/CD, is a process that takes a set of instructions and runs them over and over every time code is pushed. So in our case, every time we push, our pipeline is building the plugin and it's running all of our tests. As a result, we're getting consistent builds, and we know that our tests are being run under the same conditions every time. There's no, whoops, I forgot to run tests, or, oh, sorry, my development environment isn't really set up for testing, so whoopsie. It's also testing across multiple combinations of PHP and WordPress, and I don't have to lift a finger. I'm not maintaining multiple versions on my local development environment. CI is able to do this for me. So then when we're preparing a release, the pipeline also calls that build script in order to generate the optimized production-ready zip file. But it's only doing that after checking that dependencies are up to date and doing any other pre-flight checks that we've defined. We're able to script everything so we get these consistent results. So what kind of tests do we run? Now, if you know me, you know that I'm really big on automated testing. I am that guy. And at this point, we're hovering around 1,000 unit and integration tests using the WordPress core testing framework, which is PHP unit. So if you're new to testing, I highly recommend checking out my talk, Confidently Testing WordPress, which I'll include a link to in the resources that Brian will send out. But PHP unit isn't where we stop with our testing. On every push, we are checking coding standards. So that's PHP Code Sniffer and PHP Coding Standards Fixer. We're checking compatibility because everything that we write needs to be compatible with every version of PHP that we support. In situations where third-party code doesn't support a version of PHP that we need it to, we even have a method to patch those dependencies via Composer as they're being pulled in so that we can add the necessary compatibility. Of course, then we submit those patches upstream. But this is a system that we've had to come up with. We're doing static code analysis, so we're analyzing code without executing it. We do that through PHP Stan. We're checking that dependencies are up to date, everything that we're bundling. This isn't an automated thing, but we're doing code review. So every change to the plugin is getting reviewed by at least one person on our team who didn't write that line of code. And then finally, manual testing, because sometimes you just need to roll up your sleeves, dig in, and make sure everything is working. Now, one pain point we ran into early on was testing across multiple versions of PHP. We didn't want to abandon the customers who are still running dead versions of PHP because technically it's on us, because the few of them still running those versions, we haven't taken it away from them yet. But conversely, we didn't want to live on dead versions of PHP unit either, just to be compatible with running, say, our test suite in 5.6. So the solution we settled on was a library called PHP Unit Bridge. It's part of the Symfony framework, and it lets us run the latest version of PHP Unit based on the PHP version. Furthermore, we hacked the core test suite just a little bit to get it running on PHP 8. So now every time we push our code, it's being tested across multiple versions of WordPress on PHP 5.6, 7.0, 7.1, 7.2, 7.3, 7.4, and 8.0, which is pretty cool to see. So looking back, we're handling differences between sites, and we're toggling our features based on the customer. We're using autoloading and the DI container to keep a small footprint, and we have a consistent way of building, exhaustively testing, and then deploying this across all of our customer sites. So we've hit on all of these at this point, but there's still more we can do, especially around number 1. Now, when building a plugin, it's almost certain that unless you're building it for exactly one site, you're going to have to tangle with the issue of multiple combinations of themes, of plugins, of WordPress core versions, of PHP versions. So there are 2 concepts to keep in mind when you're approaching a problem like this. First, you want to embrace the idea of progressive enhancement. Now, if you're not familiar with the term, the general idea is to build a solid baseline, something that'll work in as many places as you deem reasonable. Then, as configuration or environment allows, you start adding or improving, enhancing features. That's the whole point of the should load integration method within the integrations. We remove it if we don't have any reason to load it, or better yet, we don't load it if we don't need to. Then, instead of backporting features to old versions of WordPress, check to see if the feature is even supported, and if so, then you load it. So for example, if there's some feature that's not critical, but it's kind of a nice to have, but it wasn't available until WordPress 5.4, and the customer is still running WordPress 5.2, guess what we do? We just don't load that feature. They just don't get that integration. It's that simple. You have to blur that line a little bit when it's something critical, but if it's kind of something that, hey, this is a nice improvement, we don't have to backport all of this code and then maintain that. Along with this, you want to define what your minimum supported versions will be. Now, this could be a PHP version, it could be a version of WordPress, or even a particular plugin version. But determine at what point you draw the line and you say anything below this, and you just use it at your own risk. Furthermore, be ready to raise that minimum down the road. Just because you support PHP 5.6 right now doesn't mean you should be doing it 6 months from now. And honestly, please don't. PHP 5.6 has been dead for years. Just let it rest. Now, in the MU plugin, for instance, we won't load the MU plugin at all for customers running anything below WordPress 5.0. So instead, we display a notice that basically says, hey, what's up? You're on this managed platform, but you're not getting all the benefits that you're paying for because you are running below the minimum required version. Please update your WordPress or you're just not going to get this stuff. So finally, as we wrap up, let's take a look at a few lessons that we've learned along the way. Now, when you start building something bigger than a typical WordPress plugin, it can be really tempting to build everything like a web application, especially if that's kind of where you like to play, where you are comfortable. But it's important to remember that you're building within the confines of WordPress, which means there are a lot of tools there for you already. Now, in our case, the MU plugin, it adds a lot, especially with things like the dependency injection container. But at its core, it's still a WordPress plugin. We're using actions and filters. We're working with the options table and user meta. We're registering settings pages using the settings API. We're not doing something like creating our own version of the WP REST API or inventing our own hook system or anything else that already exists and works well within WordPress. Can we enhance them? Certainly, but use what's there as long and as well as you possibly can. Next, it's important to remember that customers have chosen us, but not necessarily all of the features that we roll out. For us, it's kind of the trade-off in managed hosting. I mean, we want to keep pushing new features, but not everybody is going to want every new feature that we push, and that's okay. So instead, we do what we can do to give our customers a solid starting point. So full page caching, a Redis-backed object cache, and a performant theme, those are all going to be installed and configured for you right out of the box. Meanwhile, if you migrate over, or you've been building sites for years and you have a particular set of plugins that you use on every site and you love these plugins and you rely on them, we would be getting in your way if we said, nope, sorry, you have to use our thing. So the MU plugin even includes some code to deactivate integrations or features if you're using something that we recognize as, oh yeah, they already have this covered. Let's just step back, let them do their thing. Additionally, it's important to remember that the MU plugin is meant to help optimize customer sites, but some of the features are admittedly add-ons. So for example, we offer the plugin installer. It's a curated list of free and premium plugins, and based on your plan and everything, it'll say, hey, we think these plugins would be helpful. You can click here, install them. We'll handle licensing for you and everything. It'll be great. If you are running your own site, that's a pretty great feature, right? But if you're an agency and you don't trust your customers to install things because your customers are the, ooh, shiny, I'm going to install all the things and then complain when my site stops working the way I hope it will. That plugin installer could become a liability for them. So naturally, we offer a filter to enable our agencies to just turn those features off. They can opt out. Not a big deal. And then finally, when you're building, it's really important to keep an eye on the resources you're occupying by regularly measuring your plugin's performance. There are multiple ways to do this, whether you're doing load testing to see how traffic holds up, or you're profiling to determine the slowest parts of your code, but testing performance should always follow this pattern. First, you want to get your current measurements, your baseline. This is what you're going to compare all other values against, so get the before. Then you experiment. You make a little change. And what do we do after that? We run the tests again and we compare our results and we say, okay, we thought this would improve performance. Did it? Or did we make things worse? Or are things largely the same? Do we continue down this path tweaking? Or do we kind of go, nope, that idea failed? Either way, we need to repeat this until we're satisfied, until we reach the point and say, yes, we've done what we can do to optimize this. So in the talk's resources, I've included a link to an excellent talk by a developer named Kat Zien. It really demystified performance testing for me when I saw it in Austin a couple years ago. So that'll be in the resources. With that, I'm out of time. I want to say thank you all so much. I hope you have a wonderful word sesh, and I am looking forward to answering any questions you might have down in the chat. Thank you.